Okay. So I guess we did till example 4. So this answer would be 264 by 2450, or in decimal it is 0.108. Okay. Example 5. So, okay. So the probability that a student will pass a mathematics is 0.76 or 76%, and the probability that she will pass English is 0.83 or 83%. If the probability that she passes both the subject, that is maths, and that is English, is 70%, we are supposed to find what is the probability that she will pass any one subject. So that would be math or English. How do you find this? Use the formula and tell me the answer. This, or in the sense, addition rule. So use the formula of addition rule and tell me the answer. So the formula is probability of math plus probability of English minus probability of math and English, right? Now, what is the probability of math? 0.76. English is 0.83. It's already given. You just have to calculate. What is the answer? What would be the answer? This one? We have told that if the probability that she passes both the subjects is 0.70, which is AND. So your answer must be 0.89. Just add those two numbers and subtract with 0.7. Any questions? You know how to get this, right? Just use the formula. Everything is given in the problem. You just have to identify which one is which. Okay? Example 6. Okay. So sample size is given. Sample of 200 tourists, which is small n, right? 200 tourists. Now the probability of 125 tourists went to CS and 100 went to Wrigley, 70 visited both. Use the given information and find what has been asked. Look at this. It is OR, so you have to use addition rule. It's the same as we did before. You have to find the probability of, I'll just represent with S, P of S or W. Here's the same formula. You just have to identify the values. P of S plus P of W minus P of S and W. and W. What is P of S? 125, right? P of S is 125. P of W, 100. P of S and W, 70. Now, how did I get these values? Check the question. They are saying that 125 went to Sears and 100 went to Wrigley and 70 visited both in the sense and. Okay, and that's how we get these values. So your final answer will be 155. Now, they have given us the values. We did find P of S or W. But why do you think they have given this value? Observe clearly and tell me what is that 125, 100, and 70? Is that the actual probability or number of outcomes? Okay, they are just telling us that these are just the number of peoples visited. It is not the actual probability. Now, what is the probability formula? Number of outcomes divided by total outcomes, right? Now, number of peoples divided by total number of people. This will be the actual probability. The answer must be 0.775 or 77.5%. So be careful while reading the problem. You have to identify whether it is actual probability or just the number of outcomes. Solve this. And or or use addition rule and multiplication rule and solve this problem. What is the probability that the individual prefers radio? So they are just asking the probability of radio. How do you solve this? That's it. Just divide the radio with total number of radios. So radio is 175. The numbers of this is this, and this is like number of radios and total. Okay. How do I get this 450 and 1320? Check with the table here. They are asking about radio. Concentrate only on that. And we need only total. So this will be the total number of radios. We are dividing by the whole calculated total here. So whole total or the raw total will be 1320. Number of radios will be 450 and total number will be 1320, and that is why we did this. Okay. B, probability, male, and radio. So it is a connection between the males and the radio. And means both. So you actually don't have to use the formula. You can do this in another way also. So just look at the table. You will get the answer. It has to be male and also radio. 175 divided by Exactly. So how did we get this 175? Just concentrate this one. They're asking about male who prefers radio. That total number is 175. Always divide by total number. So we will get 175 by 1320. Okay. What would be the answer for C? Male or radio? It has to be male or radio. So this information is definitely not given in the table. So you have to use the formula, that is probability of male plus probability of radio minus probability of M and radio. You have this values calculated. What would be the probability of M? Yeah, the total answer is 78.4%. So what is probability of M? Yes. Yes. Why and how? We are just concentrating on male, right? So look at the total numbers. It cannot be 280 because it is related to TV. Now we don't need any information about TV or radio or NP. We just need the total number of male. So that is 760, right? So it will be 760 by 1320 is the total. P of radio is already calculated, which is 450 by 1320 minus. We also know P of M and radio. We did it in the B, right? So it is 175 by 1320. Answer is 0.784. Yeah, yes. That's how you calculate, right? Now, probability of TV or radio. Again, use the formula because we do not have any information about this in the table. So it would be probability of TV plus probability of radio minus probability of TV and radio. It is not a lot to calculate. Tell me the answer. And I need answer from these two columns. So what is probability of TV? Anyone with the answer? Sorry? Oh yeah, sorry. Probability of TV. Very good. 395 over 1320. Probability of radio. Very good. 450 over 1320. TV and radio. This is the tricky part. TV and radio. So what do we mean by and? Means both. So people who prefer TV and also radio. the information is not given here. So can we use the formula and calculate? No, because there is no connection between TV and radio. It is a separate one. So what will be the probability now? There is no probability. The probability is 0. There is no chances that they will prefer both TV and radio. Now this table, if you observe carefully, it is separated on, or it is depending only on male and female. It is just that how many males are watching TV, radio, NP, etc., and how many females are doing that. So it is not a relation between TV and radio. It is a relation between male and female. Okay, and that is why probability is 0 here, and your answer is 0.640. Okay, so this completes your section 4.3, 4.2. Let me see this. Now, section 4.3. We have already learned this, but it's just like a summary. Now, if I say that A is the event for getting at least one, it could be any event. But if I say that A is a probability of getting at least one, then A complement means the event doesn't occur, right? That is the definition we learned. So it could be getting none in that event. If I say A is at least one, then A complement is none. So we will not get nothing. Okay? And we also saw this relationship, how it works. P of A plus P of A complement is equal to 1. And why is it 1? Because P of A means event occurring. P of A bar event does not occur. When you add both, it has to be 100% or 1. Okay? We looked at one example of tossing a coin. Probability of getting head is half. Probability of not getting head is also half. Now when you add those two, the answer is 1. It could be for any event, the answer will definitely be 1. Okay? Now we know that A is defined as getting at least 1. A complement means none, getting none. So they have just rearranged it. Okay? So let us quickly go for the examples. They're asking that when 4 digits are randomly chosen, what is the probability of getting at least one of the digits is 0. So we just have to identify the events A and A bar. At least one, right? That is how we define. At least one is 0. A complement is none. None of the digits are 0. That is how we are defining A and A bar. Okay. So if you make a random guess for 10 multiple choice test question, so there are 10 questions and how many options we have? 5, right? Multiple choice. So they are saying that there are 10 questions with 5 possible answers, that is 5 choices. What would be the probability of getting at least one correct? We have to find probability of A. at least getting one correct. Okay. If a very lenient instructor says that passing the test occurs if there is at least one correct answer, so that means you have 10 questions. If you just answer one question, she will pass you. So now we have to check what would be the probability. In the other words, what would be the percentage of passing? So if you answer one question, what is the percentage that you're going to pass the exam or the test? Okay. Now let's arrange in this way. We have 10 questions. Ten total questions. So the total is 10 with five options or five possible answer choices. Now she's saying that at least one has to be correct. At least one has to be correct. Then what would be probability of A complement? We'll not write P of A, but let us calculate P of A bar. A means at least one correct. We don't know the probability of that. We are supposed to find that only. So at least one correct. Then what is the probability of not getting the answers correct? That would be 4 by 5. Why? 4 wrong answer choices. 5 means total number of choices. Okay? At least one correct. In the 5 options, if at least one is correct, that means 4 are wrong. So that is your A complement. Negative, none, not, wrong. All this belongs to A complement. Okay. Now, why are we supposed to find A complement? Because it has not been asked, right? We are supposed to find only P of A. Why? Because if you want to find P of A, the formula is 1 minus P of A complement. How did we get this? We have this relationship P of A plus P of A bar equal to 1. Now I need P of A, so I will move this to the other side, which becomes P of A complement. That is how I get this formula. Okay? Okay. Now I know that P of A bar is 1 minus 4 by 5 because A complement. Okay? Now tell me if I did this correct or wrong. We are talking about 10 questions here, but the probability is here is only for one question, right? I need for 10 questions. So how do I do this? Now I cannot change this to 50. 10 questions, 5 multiple choice answers, so 5 possible answers, multiply 50. No, that could not be the total. If that is the total, then this will be wrong. So in that case, we are going to multiply 4 by 5 10 times. Do not multiply whole thing with 10. You're going to multiply 4 by 5 10 times. Okay? Then this would be 1 minus 4 by 5 to the power of 10. So if you use a calculator and do this, the answer is 0.8. So answer is 0.893. Now what is this? This is the probability of getting wrong answers, of getting wrong answers for 10 questions. Okay. Now P of A is the probability of getting at least one correct for 10 questions. Getting at least one and getting wrong answers. And this is for whole 10 questions, not for a single question, for all the 10 questions. Okay, so what does this mean? It means that there is a 89.3% chance, or roughly 90%, I can say 90% chance that you are going to pass the test by answering at least one correct answer among 10 questions. Done? Okay. Example 3, you have to do this. It is the same problem with the numbers change. E event means at least one defective. At least one defective disk in a lot of 50. A complement, none. None of defective. None of them are defective in a lot of 50. So total number of disks is 50 in a lot of 50. And they have reported that the defective rate is 0.5%. They have not mentioned whether it is for one disk or all 50 disks. They're saying that the defective rate is 0.5% and the probability of individual disk, now they have already mentioned it as probability, so you do not have to divide it by 50. Now the probability of individual disk to be defective is 0.005%. Okay, then the probability of a disk being good is 0.995. 0.995. Now they are asking that what is the probability of getting at least one defective disk in a lot of 50? At least one, which means you have to find P of A. That means P of A bar must be given. Find P of A is equal to what? This is for P of A for 50. Is P of A bar given? No, it is not given. Then what is given? They have given the value for individual disk being defective. Okay, at least one is defective. That means P of A is given. P of A is 0.005. This is for one disk. Do not get confused here. We are talking about 1 versus 50. Okay? Then what is probability of A complement? It is 1 minus 0.005 by the formula. Then the answer must be 0.995. Now remember, the answers which we got here is only for one disk. Now, if I want the answer to be for 50 disks, what are we supposed to do? Multiply 50 times or to the power of 50. So what to the power of 50? Is it P of A or P of A bar? P of A bar, right? So it is to the power of 50 because the total number is 50. Now this answer is for all the 50 disks. Now the question is been asking for P of A for 50. Okay. Now again use the same formula, reuse it. P of A is 1 minus P of A bar. That is 1 minus 0.995 to the power of 50. You can use your calculator and the answer must be 0.222. Okay. Do not get confused here. They have given the information of one disk and we are supposed to find for 50 disks. In that case, you have to find probability of A complement or for one disk. So to find for the total disk to the power of total number, you'll get a total number of disks. Okay, and use that and find P of A for all the 50 disks. Right? Next question. So here the total number is 2. So they're saying that, mark it here. So they're saying that a student is planning to use a calculator for a final exam. Now, from the past experience, she estimates that there is only 0.91 or 91% chances that the calculator will work. That means the rest of the percentage, the calculator will not work. So what will she do? She will use two calculators or she will take two calculators for her final exam. So it has been given here. So what is the probability that she will be able to complete her exam with a working calculator? So we have to find probability of one calculator. Does she really gain much by bringing another calculator? So in other words, what would be the probability of her facing troubles if she had not brought the other calculator? Okay, that is what we have to find. So probability of A, that means one calculator, is 0.91. So what would be the probability of that calculator not working? 1 minus 0.1, which is 0.09. There is only 9% chance that the calculator will not work. Okay, now this is only for one calculator. We have two calculators. Now, if I ask you, what is the probability that the calculators will not work? Total number of calculators. So what would be the probability then? There are two calculators. What is the probability that both calculators will not work? So how did we get that? to the power of 2, or multiply twice, to the power of 2, whenever you have a total number, to the power of 2. Now we know this is for two calculators. Now, what is a probability that it will work? Both the calculators will work. It's going to be use the same formula and find the answer. So this is exam with a working calculator. With working calculator. There are two questions to be answered. First question is done. Okay. Next question, does she really gain much by bringing the second calculator? So exam without a working calculator. Now, with one working calculator, what is the probability? With one calculator, the probability was 0.09 with one, right? Now, with two calculators, probability would be square. We're talking about without or none or negative, so it has to be a complement. This is 0.081. Okay, so this is the answer for second question. So now just to summarize, probability, the probability of taking the exam without a calculator, without the backup calculator, drops from 0.09 to 0.0081. That's the conclusion. Okay. Okay. Next is conditional probability. We have learned about this, so I will not go much into that. Just make a note of this formula. We will be using this in the example. P of B by A, which means the probability of event B occurring, assuming that event A has already been occurred. So event A has already been occurred. We just have to find the probability of B. Okay, that's the meaning of that. Now, this is the data given here. If one of the 555 test subjects is randomly selected, find the probability that the subject had a positive test result given that the subject actually uses drugs. Now identify event A and event B. This is event A and this is event B. Okay, first event, take it as event A. The next event, take it as event B. Now, we need to find out what is the probability of positive test result given that the subject has already actually uses drugs. So the event B has already occurred. Okay, now we need to find the probability of the A, assuming that B has already occurred. So in that case, use the formula which is equal to P of B and A divided by B and A divided by probability of A. So before that, let us calculate this. 50, 505, this is 70, this is 485, plus 555. How did I get all these numbers? Just have to add the rows and the columns. That's all. Okay. Now, what is probability of B and B? A subject actually uses drugs and also tested positive. 45. Right. 555? Okay. Now, P of B and A is this, right? Subject uses drugs and is also tested positive is 45. Divided by probability of A. What is A? Positive test result. Now tell me the total number of positive test result. Oh, sorry, formula is wrong. B and A divided by probability of B. Now B event is using drugs. So this will be the total number. The total number is subject uses drugs. The total number of subject uses drugs is 50. Okay, that's a small correction there. Point 900. It's so slow. Okay. Now answer this question. It is similar to your first problem. Okay. Calculate and let me know the answer. Probability of B by A. Oh, I'm sorry. So it is probability of subject uses drugs divided by positive test result will be equal to probability of B and A divided by probability of B. What would be the answer? If you're getting confused with A and B event, you can just think it of subject uses drugs and a positive test result. It is just a reversal case of these question A. Now, probability of B and A, is it equal to probability of A and B? No. Okay. So if I say that in the previous question we saw about male and radio, right? So the number of male who prefers radio, the number of males and also prefers radio, is that equal to number of people or the individual referring radio, and it has to be male. Okay, so let me write it here. Now I'm talking about male and a radio. Okay, if I say that the probability of male and radio is that equal to probability of radio and male. Okay, it is equal. Why? For example, let's give it some number. Say 50. So the probability of male and a radio is 50. Now tell me, what is the probability of a radio and a male? It has to be like he has to prefer radio and it has to be male. Same. So there is no much change. That means there is no change in the numerator. I said you that this is just a reversal case of question A. A. Okay. So now we are just reversing the case, that is B by A. So this would be A and B, and this is A. So 45 will be the same because A and B and A both are same. Changes in the total number, and now tell me what will be the total number. So what is probability of A? Now A is nothing but the positive test result. This is B. So what is the probability of A, or the total number of A? Just look at the table here. Probability of A is 70. Okay, probability of A is 70. Because we are just finding for probability of B by A. We're not finding P of A. Oh, you mean probability of A is that divided by total number, right? Okay, good question. Now tell me probability of A and B. Just the probability of A and B. We know it is 45, right? Divided by total number. That is 555. Agree? Now the probability of A is what? 70 is the total number you said, divided by 555. Now divide these two and tell me the answer. Yeah. This and this get cancelled, and that is why we take the actual number here. That was a good question. So this is 70. So 45 by 70 is 0.643. Now solve example 3. Okay, no time. Fine. We will do this in